Gulak, the founder of BPG Werks in Somerville, Massachusetts. So Ben, if you want to give a little intro about who you are and what BPG Werks is all about.
So I started the company four years ago now with a friend of mine up in Canada. We had this idea to make a new kind of off-road vehicle. We noticed that there's a gap in the power sports market. There's an aging demographic, and me and him grew up skateboarding and doing motocross, and extreme sports have been the fastest growing demographic for the last decade. So we thought if we could make a new kind of vehicle that would get more of these extreme sport guys out enjoying the outdoors and make something fast enough where they could hurt themselves on it, hopefully there'd be a market for it. So we started building a prototype in the back of a shop up there, and 4 years later, we've just closed a big venture capital round. We have scaled out, and now it's no longer just us. We have a pretty big team of engineers, and we're about to release our first product this December.
So I'm Dan Arnold, I work at BPG Werks, Somerville, Massachusetts. Been here over a year. And what we are is we develop cool off-road products, new to the market. We have a few balancing motorcycles, and the newest product is a tank-treaded skateboard vehicle that you stand up and ride. It's new to the power sports industry.
We started off the Shredder as a completely new all-terrain vehicle. It breaks all kinds of boundaries. It's the first true vehicle that you can ride all year round on sand, snow, mud mountains. It breaks all these boundaries. We already have a bunch of military interest. I don't know if you guys saw the military prototype out there, but we're on a path in that direction, and I think the power sport industry has been really stagnant for a long time. Things get faster, but bikes and ATVs, they've essentially stayed the same for a really long time. And being at MIT, I get to see all this really cool new technology, and I'd love to bring some of that really high-tech stuff into the power sports industry and build more fun, dangerous things.
What's the design cycle like for you?
The design cycle, the engineering design cycle, starts with brainstorming. Starts with the idea. It's done on paper, discussions, meetings. From that, early development's done in CAD to really block out the design, not going too far into the details. And then the following months, you kind of chisel away at the design and design in the stuff that was unanticipated, and then try to line up manufacturing. That's a whole other science in itself. After designing parts, we come up with a plan on problem items that could lead to fatigue issues, that sort of thing. We come up with a plan on loading scenarios and run some weldments and assemblies through a process. And what it allows us to do is it allows us to verify or be in the ballpark of where we want to be structurally before we ever build. And field testing can then be the ultimate verification that it's strong enough.
So I'm guessing EPDM is helping you guys out with the revision control and
Yes.
SEO type stuff?
Exactly. We just got up and running with the EPDM exactly for that reason, to lock in revisions.
So when you guys are creating these parts before it goes to manufacturing, how were you guys creating prototypes?
We were creating prototypes by various methods. Most of the parts on the machine are metal. They're machined. Some of them are stock parts, but we have various machine shops making parts. And there are a handful of parts that we need a 3D printer to make. The idea would be that if we could get a printer in-house, we would have the ability to print anytime. So we'd be controlling the process. We wouldn't be waiting days for a quote, plus days for manufacture, plus days for shipping. And it would essentially allow us to print multiple variations for the same cost. We did, in fact, look into printing this part right here, and I believe previously costed about say $500 to print. And after looking into the cost of materials for a 3D printer, if we could do it in-house at cost, it could be a third of that.
All right, so they've got their U-print in-house now, and they actually have it printing as we speak. I understand it's actually printing one of these. So Dan, what is it that you guys are printing right now?
So these are an air intake duct for our transmission on our prototype machines. This particular one is a part that came from another manufacturer. It was done with some sort of rudimentary tooling, blow mold, something along those lines. Fairly expensive in small quantities. with the printer, we've been able to print versions from scratch of this exact part. They're identical. Turnaround time is about, I don't know, 9 or 10 hours a piece. And basically it comes out looking like this with the support material. We break this off and dip it in the solution. Inside the printer right now, you can see we're printing multiple ones at a time. There's 3. Printing vertical.
So why did you change the orientation of this part compared to how it's printed here?
So we played around with a few different ways to print this. The system chooses how to support the part. So with the large amount of heat inside the machine, the part doesn't basically droop or melt away before it can print. So some of the first passes we did, we printed, we'll say, horizontal like this, and the machine fills that area in with a support. This next batch, we played around with printing it vertical. We had to twist it a little bit to fit it inside the window, but it appears as though it's printing far less support material, because inside this hollow section, it doesn't need to actually print. It just needs to support the pieces that hang over the edge.
Yeah, so as a tech tip for anyone that's using these printers, any surfaces that are over 45 degrees, that's actually when the support material comes into effect. So the way that they've oriented it, they're reducing the amount of support material they actually need to use, and it's fairly simple to do inside the software.
Yeah, the software is actually automatic. There's a few different settings.
Right.
You can choose how dense you want to support this. We find that for most of our parts, the less dense options, where it kind of builds a grid inside, it doesn't build it solid. It works just great.
Great. So you're using less support material and less time. Biggest benefit that you've seen so far?
Biggest benefit, absolutely cost. Mm-hmm. It's going to save us. It's going to save us by the time we're done here, of 2 to 3 months of printing. I would guess it's going to save us somewhere in the $10,000 to $20,000 machine.
Wow, that's a big
range,
number.
I would guess.
For just having a printer in-house now.
Yeah, I mean, basically purchasing the machine is, basically it would open up the door to purchase the machine, which would open up the long-term benefits of this.
So what about having the printer now and its effect on the design cycle?
It's sped up. Our turnaround times, which is huge. We have a release date for this machine set for end of the year. And we have 8 units that need to be fitted with these parts so they can go through environmental testing. So every day that we save helps the timeline.
Yeah, absolutely. Do you guys think now that you have it in-house, or when you're actually designing parts, do you think, oh, I'm just going to print it out on the machine and see how it works?
Yeah,
that's
absolutely.
Yeah.
It's like another tool in the tool belt. I could see, any small, medium engineering company could have use for it, as well as into the art industry, where anybody who's doing graphic design could basically prove out or even build something, literally printing it.